Hello everyone, welcome to Vijay Chemistry channel. Today we are going to discuss about density. Density. What is meant by density? Density is nothing but at STP conditions, mass of gas per unit volume. At STP, standard temperature, pressure conditions, mass of gas per unit volume. Formula: density is equals to mass of gas. Mass of gas may take in grams or kilograms per unit volume. 1 mole of any gas occupies 22.4 liters. Okay, in that way, mass of gas per unit volume. So, what are the units for density? Units. Grams if we take in milliliters or gram per cc centimeter cube. 1 centimeter cube is equals to 1 milliliter. No, we are taking in kilograms at the time. Volume in liters. Kilogram per liters. Or 1 meter cube is equals to 1 liter. Kilogram per meter cube. This also we can use. Okay, these are the units for density. Okay, density means mass of gas per unit volume. Means mass by volume. Simply what it means. Mass of any substance is directly proportional to density. Means mass increasing, density increasing. What about volume relation? Volume increasing, density decreasing. So mass is directly proportional. Sorry, density is directly proportional to mass. Density is inversely proportional to volume. Okay. Now see here. For example, let's say STP conditions in unit volume. Its capacity just consider 1000 liters. 1000 liters container capacity. And I'm taking 1 kg ice cube. 1 kg. Okay. 1 kg ice. Ice is in solid state. Particles are tightly packed. So weight is 1 kg. Mass is 1 kg. But occupied volume is, just consider this volume occupied how much? 10 liters volume occupied. Total container capacity 1000 liters. But the ice cube occupied volume is 10 liters. Next, in another container, same capacity container volume, 1 kg water in liquid form. 1 kg water. Here also amount of substance is 1 kg only. But volume occupied 100 liters. 100 liters. Next container, it is in vapor state. So closed container we are taking with the same capacity. vapors. Vapors negligible attraction between the particles, so it can move. It can occupy complete volume of the container. So they occupied 1000 liters volume, even though amount of substance is 1 kg only in all three cases. Here also 1 kg, here also 1 kg, here also 1 kg substance. But the volume occupied by the based on the physical state of matter is different. Now, for our understanding, easy to calculate mass by volume, go for density calculation. Density of ice cube. Mass, how much? 1 kg. Volume, how much occupied? 10 liters. Next, same calculation, go through the water. Mass is how much? 1 kg. Volume, how much occupied? 100 liters. Same calculation go for vapors. Mass is 1 kg. Volume occupied 1000 liters. Yes, if you calculate here 0.1 kg per liter, here 0.01 kg per liter, 0.001 kg per liter. So through calculation also we are getting here the density is directly proportional to mass, inversely proportional to volume. More volume occupied, lower density. Less volume occupied, more density. Here, volume changes we observe. Okay, so like this, we can go through the more volume occupying means more air gaps are there, so they have a lower density, even though mass is same. When the particles are attracted more tightly packed, they have more mass. But here, one small instead of ice, because ice is the exceptional case, it has open case structure. That is what ice having lower density than water, even though solid. So small change instead of ice, we can take any other solid substance, any other solid. Because if you take ice, there will be again controversy. Because ice, even though solid, float on water. Because open case structure, they having porous air gaps. Due to that, ice is solid, but it has lower density than water. So just instead of telling ice, ice is not just one solid substance other than ice. Okay, this is the information about density. Next, what is vapor density? I hope you understood density. Now, what is vapor density? What is vapor density? Vapor density. Vapor density means it is the ratio of density of gas to the density of hydrogen gas. It is the ratio of density of gas to the density of hydrogen gas. This is the ratio of density of gas to the density of hydrogen gas. Means they will give you the question density of so and so gas. So at the time vapor density we need to find out means given gas in the question divided by density of hydrogen gas. Okay, we will get vapor density. So formula vapor density VD. VD means vapor density. D means density. VD means vapor density. Density of gas by ratio. It is the ratio. So ratio. Density of gas to the density of hydrogen gas. Density of hydrogen gas. So we can calculate here density of hydrogen gas. One time if we calculate, it will be fixed. See mass of gas. Mass of gas hydrogen gas is 2. H2 diatomic form. By 1 mole of any gas occupies 22.4 liters. 2 by 22.4. You will get some value. That is the density of hydrogen gas. Now, here vapor density do not have any units because here also density, here also density. So density units will get cancelled. So they do not have any units. Vapor density units of vapor density. Vapor density not having units. Vapor density not having units. Vapor density not having units. Yes, one more short form formula for vapor density. Vapor density is equals to molecular mass by 2. Molecular mass divided by 2. At the time, we need to get a molecular mass. Molecular mass, they given in the question vapor density value. They are asking find out the molecular mass of the particular substance. At the time formula, molecular mass is equals to these two if you send this side 2 into vapor density. 2 into vapor density. Okay. Thank you, Chamal. Overgone. Thank you to all.